Hello everyone, welcome back. Today we're going to have a little discussion about the search for life in the universe, right? We're going to be talking a little bit about cosmology. Once in a while I do a video on just a completely different topic. This is a subject that is interesting to me. I've done videos on this in the past. If you search my channel name and the word cosmology, you should find some of the older videos I've done on this subject. So today I want to specifically talk about the search of life in the universe or off planet, right? And usually when if you watch these science shows, right, or science videos that are posted on the internet, and you'll find that they're usually looking for what they call a Goldilocks zone, right? They want a planet where the temperature is going to be somewhere between where water freezes and where water boils, right? So it's got to be somewhere between, let's say, 32 degrees and 220 degrees. That's where they typically look for, a place where life, as we know it, has a chance to develop. Now, one of the things that they usually don't mention is that Goldilocks zone doesn't have to be on the surface. Okay, it can be under the surface, and in fact, if you have that Goldilocks zone under the surface, there's probably a better chance that it is going to be more stable. The surface of planets and the atmosphere tend to be less stable temperature-wise. Just because you've got winds, versus underground where it's more solid, there's less of a chance that the temperature is going to fluctuate. So here's the other important component to understand that as far as this goes, that any Earth-sized planet, more or less, but any planet that is about the size of the Earth is going to be, or bigger, right? It can be about the size of the Earth or bigger, is going to be alive. Okay, now what do I mean by alive? I don't mean that things are necessarily living on it or in it. What I mean is that it is capable of generating its own heat. So look at the Earth is big enough so that gravity will crush down on it, onto its core. And as the molecules in the center of the Earth get pressed together, they generate heat. Okay, so even if the Earth wasn't getting heat from the sun, it would be able to generate its own internal heat. Now, here's the thing: the surface of the Earth would probably be like, well below freezing, because it, let's say, wasn't getting enough heat from the sun. But somewhere under the surface, right, where someplace between the core of the Earth, which was like, and I believe they say that the core of the Earth is almost as hot as the surface of the sun. So somewhere between that hot core and outer space, there's always going to be a place where you're going to find that Goldilocks zone, where the temperature is somewhere between 32 degrees and 220 degrees, right? There's going to be a spot somewhere. It might be, on Earth, it happens to be on the surface. Now, okay, that's not where it was, 3 billion years ago. That's not where it might be 3 billion years from now. But for right now, that Goldilocks zone, it happens to be on the surface. So let's say you go to a planet, let's say like Jupiter, right? Huge gas giant. It's because it's so big, again, gravity, crushes down, and it has a hot core. So now it's a gas giant, but if you go through this planet, and you go at some point, some point towards the center, it's going to appear like it's going to be what we would call almost solid. So the gravity is going to crush those gases or compact those gases so that they appear, to be almost solid to us. And then as you get further out, they become more gas-like. Well, somewhere between that hot core and outer space is going to be some area where you've got that Goldilocks zone. Now, Jupiter, as we were able to observe, has a very violent atmosphere, right? There's storms, windstorms that have been raging for, like, as far as we can tell, as long as we can tell. Okay, so because of these windstorms, that spot where you've got that Goldilocks zone, it probably fluctuates a lot, like probably from second to second, right? So it's not going to stay stable for long enough where you can have bacteria develop, right, and live. Okay, but that's now. You know, maybe it was different. I don't know, a billion years ago. Maybe it will be different a billion years from now. But the fact is that you have a planet that's alive, and what I mean by alive, it's able to generate its own heat. And somewhere between that hot core and outer space, you know, you're gonna have that Goldilocks zone, and at some point in time, the atmosphere may stabilize enough or stop or not be so violent, so that you can get you can get a stable Goldilocks zone, as people typically, or scientists rather, refer to it. Now, on I think that on a lot of planets, it's going to be under the surface, because given that the solids tend to be more the temperature of solids tends to be more stable, right? So if you have you can have a planet, like for example, let's say our sun started cooling or something, right? And we weren't getting enough heat, right? And the surface of the Earth completely froze over, right? Well, actually, let's say when we had the, I don't know, last ice age, right? Or there was actually a period in time where the whole Earth had kind of turned into a snowball, right? The whole Earth had froze over. They called it snowball Earth. So during that period in time where the Earth was completely covered in ice, right? Completely covered with ice. It still had a hot core. So somewhere between the surface and the hot core, there was a zone where it would have been about 70 degrees. And because it's underground, that zone probably would have been a lot more stable. And that could have been a place where bacteria would have been able to, to survive and thrive and basically, mutate. Okay. So I just wanted to kind of put that out there. I find that very interesting. The idea here is that any Earth-sized planet, right, and it could be a little bit smaller, it could be a little bit bigger, right, because you can have a planet like that's smaller than the Earth, that's just more dense, so it's still able to generate heat, or you can have a planet, that's the size of the Earth, but because it's, let's say, it's not as dense, can't generate its heat, but one slightly bigger will generate heat. But on average, if you got most Earth-sized planets, are going to be able to generate their own heat as gravity basically makes the planet crush down on itself. And someplace between the core and out of space, right, there's going to be that Goldilocks zone. Now, it may be unstable, it might be rapidly changing, but hey, over millions and billions of years, there might come a time where it kind of stabilizes, right? And bacteria can start to develop and form and all that stuff. So just something interesting that I wanted to put out there. I watch lots of different science channels when they talk about like the search for life and stuff like that. And this is not something that is typically brought up or discussed. And I was like, I mean, to me, it's very logical, right? It seems like most scientists agree that any Earth-sized planet is going to have internal heat because of the gravitational forces that crush down. Everybody agrees that outer space is really, really cold and nothing can really live out there. Someplace in between, you're going to have a Goldilocks zone. It may not be on the surface, it may be under the surface, or it may be somewhere in the atmosphere, but it's going to be there. So hope you guys found this video interesting. Drop some comments below. Part of the reason why I like doing these videos like this every once in a while, aside from the fact that it's interesting, it also brings other people to our channel, to this channel that we have here, who come here for this material, or to hear about this, but then also see other things I have in my channel, and all of a sudden they start becoming interested in that. So that's one of the reasons why I try to expand beyond just doing just one thing, or talking about one subject. So drop some comments. If you're not a member of the channel, subscribe. I'll talk to you guys soon.